All right. So, first of all, what should you do in this problem? Graph it. Graph it. First thing you should do is graph it.
If you just got a notification from me asking for control, I didn't mean to hit that. I'm sorry.
I didn't.
Okay,
I didn't.
yeah, I just didn't mean to hit that button. My bad.
So I sent you this one. I was able to solve it, but I had to look up what that.
Yeah, no, you don't even have to. I appreciate your email. I sent you one back. I appreciated that email. You don't even have to look up. That's not even relevant.
It didn't matter. I was able to solve it. I'm just like, what?
All you need to do is graph it. So let's graph it. So I'm gonna graph it, and I'm not even gonna look at the rest of the stuff because that don't matter. Y is equal to, and I'm gonna clear the first one, and I'm gonna clear that other one. So I want each of y'all to graph it on your graphing calculator. And y is equal to, parentheses, I'm going to have to pull mine up. Second natural log e to the x plus second e to the negative x close parentheses divided by 2 and graph. And what is the big deal? All it is what? Somebody tell me what it is.
Parabola.
It's a parabola.
A curve.
It's a parabola. I'm going to do a zoom standard or zoom fit. I don't care. 6. Is the function continuous? Yes. It's continuous. It's got arrowheads on the end of it because there's no open circles or closed circles. It's continuous. Negative infinity is positive infinity. I mean, positive infinity is infinity. Negative infinity is infinity. And it crosses the y-axis at 1. What I'm trying to get y'all to understand is just because the chapter is about limits doesn't mean you just clam up. You understand what I'm trying to say? The 15 people that I was talking to a while ago, why haven't you tried any of these problems? It's like you went, okay, that's chapter 2, that's limits. I'm just going to cut it off. Not even going to try it. That's what I don't understand. So, and that's, as x approaches infinity, you got infinity. As x approaches negative infinity, you got infinity. Those two arrowheads, where are they going? This arrowhead right here, where is it going? It keeps on what? It keeps on going. So it doesn't matter whether you're coming from negative infinity or positive infinity, the x's are going to keep going. And what is your y-intercept? This is a great test question. And somebody tell me how much calculus and limit is in this.
All of it.
Actually,
not much.
none. Because, well, yeah, there is right
It's
here.
graphing though, mostly.
Yeah. I hope y'all understand what I'm talking about. I really feel bad, but you know, 2 or 3 is okay. 15 people? 15? Really? All right. Okay, here's a question I got. This is a test question. And this one is not that bad, but it's 100% algebra. If I can find it, I don't know. I might have deleted it. I think I actually deleted yours, Miss Hunt, but I already went over it. Miss Hart, sorry. Let's see if this is the one that I'm thinking about. Okay, this one, 3 or 4 of y'all sent this one. Okay. This one is where you have to read. Okay. Do you remember in the video, for some of y'all, for the 13 or 14 that watched the video, I told y'all that when you have a fraction and you're doing it algebraically, you have to think about 1 plus infinity over infinity, like that. Or you have to think 2 over 3, which is 2/3, or 2x over 3x, which is equal to 2/3 because the x's cancel. You know, when we went through those in the video, well, this one is kind of like that, but they've got it written in a way that does nothing but what to the student? What does that do to the student? Come on, spit it out. It confuses the student. This right here confuses the student. Basically, what they're saying is, if you have f of x over g of x, what is the limit as x approaches 5? But you have to remember that g of x is positive and it's approaching, I can't spell, 0. Now you're really going to get mad when I show you how to do this. Negative 250 over a positive number is equal to negative, and it's approaching 0. Is approaching 0, not 0, okay? Now everybody needs to is that 0 or is that approaching 0?
Approaching.
So tell me how big those numbers are. Somebody tell me. If you're approaching 0, tell me how big those numbers are.
Very small.
So what is 250 over very small?
Infinity. Negative infinity.
A really big.
It's going to stay on infinity. But what's a positive divided by negative?
Negative.
That's it. And you got to read this right here. Y'all see that g of x is greater than 0? That's the kicker right there. What if it said g of x is less than 0?
It would have been a negative over a negative.
Which is?
Positive.
So this is a test question. Do I agree with the way it's written? No. But it is a test question because it's sweet and simple. Hopefully, some of y'all are going, you know what, this ain't that bad. Hopefully, you're saying that. And I'm talking to the ones that sending these questions. Some of y'all that are on 2.1, y'all don't need to talk to me right now because you're going to make me mad. Okay? Here's a test question. Okay? This test question, suppose in the position of an object moving along a line, this right here, I want you to put rate of change right above that. I want you to highlight that, and I want you to say rate of change. Could somebody tell me what an algebraic word for rate of change is?
Secant.
Acceleration.
Starts with S.
Secant.
Slope.
No, you got it close. I'm sorry, what'd you say?
Slope.
Slope. Write that down. Rate of change above that, and then equals slope. Now, I want you to think about slope, and I want you to tell me which one of those looks like the slope.
See.
Which one of those looks like the slope? So all it was asking, whoever sent this question, all it was asking was the slope, basically. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's not that one because that's a plus. It's not this one because it's backwards on top. And it's not this one because it's backwards on bottom and top. Now, I like that test question because, one, I wish they would put in parentheses right here, I wish they would put rate of change or slope. I wish they would put something like that right there because that would make that would send a flag up. So I hope that helps. Next. That's another one of those. Okay, this is another one. That's the same one we went over. I went over that. That's 21. I'm not going over that one again. This one, just work through this one. Just remember the most tedious part is having to do the 0.01, 0.1, 0.01, 0.001, and 0.0001. And after that, it's just fill in the blanks. But I'm not going to answer that question on the test because it's too busy. It's too tedious. Same type. I got another one to go over, so don't worry. I got plenty. I don't know why I hadn't hit the one. I've got 2 or 3 left. These are all good test questions, too. The ones that I've got left. There it is. That's a good test question. And the reason this is a good test question is it's not as difficult as it looks. Okay? You could graph it if you want to, but I'll tell you right now, when you see one like this that has W to the blank greater than 1, you're going to do those rules that I taught you in Thursday's video. Let's see if I can find this one because I think I got 3 of these. And I'm going to let y'all do. Yeah, this is it. This is the only one left. Now, those questions that were sent today, I'll try to get to those tomorrow. Let's see. This one says 12. I got that one right here. So what do you do first? Well, you're going to have to divide by something. Because as I told you, when you've got degrees on the numerator and denominator, you're going to have to divide by something. So here we go. And this is a test question, so make sure we're going to do 2 or 3 of them. And I'm just going to take up the whole because I really don't need that homework problem. There we go. So limit as W approaches infinity. Another key, when you see approaching infinity, that's the last part of the algebraic video that I told you that you need to what? You need to do it by algebra. You need to divide something into something. So that's 12W squared plus 4W plus 5 over the square root of 4W to the fourth plus 2W cubed. Now, what is the highest thing to divide by? Well, first of all, you can't go by the radical. You have to take the square root of that W to the fourth. So if you think about that W to the fourth being squared, take the square root of it, what's the highest degree of the numerator and denominator? W squared. So I'm going to write square root of W fourth is equal to W squared. So I'm going to divide the top by W squared, and I'm going to divide the bottom by W to the fourth. And it's going to look like this. So I'm going to write this, and I'm going to put a pink highlight on that right there. And I'm going to put a yellow highlight on this. Right quick, what's the square root of W to the fourth?
W2.
Okay, so W2 is equal to W2, W to the second power. I'm not pulling any shenanigans here. So 12W squared plus 4W plus 5 over the square root of 4W to the fourth plus 2W cubed. And I'm going to put doing my animation for y'all. And I'm going to divide on the top by W squared. And I'm going to divide the bottom by W to the what?
Fourth.
Now I want you to simplify those, and I want you to plug in infinity. And I guarantee you most of you will get it right.
So I've kind of taken the first part of this Calc 1 before, and my other teacher crossed off the numbers that didn't have the W2. Like, so the W4 and the 5, he would just cross them out.
That's another way of doing it. But the reason I don't do it is I don't assume that you know how to do that. So I just take it to the basics. I'm doing it in a more basic way.
Okay. I was just wanting to make sure I wasn't.
Yeah, it's the same thing. Only they're
so.
thinking 2 or 3 steps ahead, and I'm not doing that.
Okay, cool.
I want you to know what's going on. And then later on, you can say, well, you know what? That's going to be a fraction, so I might as well just cover that term up. So cover that term up and cover that term up. That's the way they do it. So you can either say cover it up or just take it out. And you're left with 12 over 4, whatever the case may be. 12 over 2, whatever. But I'm showing you why you get that.
Okay.
So here is the condensed version. So that cancels. Let's do a red marker. Put emphasis on the canceling. And that goes to a 1, W to the first, and that stays. That goes out, and W over what? W, wait a minute. That'd be 2 over W. There we go, right? So that's going to be 12 plus 1 over infinity plus 5 over infinity squared over the square root of 4 plus 2 over infinity. And somebody tell me what happens to the 1 over infinity and 5 over infinity and 2 over infinity.
Approaches 0.
Goes to 0.
There you go. And what's 12 over 2? And
6.
you feel good about yourself.
Which that's why he crossed it out. Because
Yeah.
they're 0. So, okay.
And sometimes if you see that, great, cross it out. But if you don't see it, then this is what you fall back on.
Well, I never understood it whenever he did it. He just said to do it, and I didn't know why, but now I know why, so that's helpful. That's why I sent this question. I got the answer right, but I didn't know why.
That's what I don't like. I don't like to teach that way. So, all right, let's do a nerd. Because like I said, I got about 4 of these. And I think I did 3. So we're going to do another one. All right, so 24. And this is a test question because the reason I like to do this for a test question, if you can do these on my chapter 2 test, then you've got limits. You've got them down. That's why I like to give these on chapter 2 test. 2w squared plus 6w plus 5 over square root of 9w to the 4th plus 5w to the 3rd. All right, I'm going to give y'all a minute to do that. Limit as w approaches infinity.
I think someone's got their hand raised, maybe. O'Quinn.
Somebody? Oh, I don't like him. What does he want? What do you want, Mr. O'Quinn?
For the test, I was just wondering if there'll be any interval questions in general.
No, I don't ask those questions. Basically, what I've told you is going to be on the test. That's what's going to be on the test. I don't try to trick you. I want you to be able to do the mechanics for limits.
Gotcha.
Okay. I don't want to see if you can tell me who attended Wimbledon and what were their addresses. That's not my, I want you to be able to do the mechanics. These problems right here, this one, the one we just did, and this one, and some of those where I asked you to graph it and then tell me about it, that's what I want you to be able to do. Because I'm going to be honest with you, I need to get chapter 2 out of the way because chapter 3 is where we really need to be. I mean, we're not behind or anything. We just really need to be in chapter 3 because that's where the calculus is. So here we go. I'm going to go over here and I'm going to use my pink. Let's see, there's my pink and my yellow. So the square root, no, you're not going to be able to see that. It's my orange. I have a fluorescent orange somewhere. There it is. So the square root of w to the 4th is equal to w what? Squared. So divide the top by w squared, divide the bottom in the radical by w to the 4th. Does anybody know why I have to use w to the 4th? Because I can't distribute w squared across the radical. But I can multiply by 1 over w to the 4th, the square root of 1 over w to the 4th into the radical. That's the derivation behind that. In other words, I can multiply this one right here by 1 square root of 1 over w to the 4th. Y'all see that? And what's the square root of a times the square root of b? The square root of a times b. So I can distribute that radical with this. That's why. So I'm going to do 24 limit. Let me do this before some math police come through the screen at me. Okay? And that's going to be 24 w squared plus 6w plus 5, the square root of 9w to the 4th plus 5w to the 3rd. And I'm going to divide this by w to the 4th. And I'm going to divide the top by w squared. Isn't it just the way, I just pick colors and it just flows. Y'all are just impressed, aren't you? No comment? That's okay.
Sure.
Now I'm going to take my red marker. I'm going to take those two out. And technically, what do these go to with the limit with this right here? What do these go to? This goes to 0, that goes to 0, that goes to 0. And what's 24 divided by 3?
8.
And you feel good about yourself.
Do you have one where they don't match up so nicely? Or is it
What?
always going to do that? Like
What?
the W2, how it always is going to cancel out with the one on the bottom, and you're going to have just two nice numbers to divide by. Does it always
Most
work
of the
out that way?
time, yeah. I haven't seen one that does anything but that. I mean, I've
Okay.
got one more, but they most of the time. Remember, again, I'm not going to try to trick you. If I've got a choice between a problem that's doable and a tricky problem, I'm going to put the problem that's doable. Now, I don't mind challenging you, but tricking you is something else. All right, let's try this one. And if you can do this one, you're good on those three. Limit as w approaches infinity of 72 w squared plus 4w plus 2 over the square root of 64 w to the 4th plus w to the 3rd. Give y'all a minute or two. So, limit as W approaches infinity. And I'm going to put over here, I'm going to put the square root of W to the fourth. And I guarantee y'all, some of y'all are already skipping steps.
Priority 1 message coming in on secured channel.
I guarantee you, some of y'all are doing this. You're doing, that goes out, that goes out, that goes out, that goes out, and that goes out. Aren't you? No? Okay.
Sorry, there was a lag.
Oh, okay. 72 plus 4 over W plus 2 over W squared over the square root of 64 plus 1 over what? W. And this goes to 0. That goes to 0. That goes to 0. And 72 divided by 8 is what?
9.
And that's your answer. Now let me ask you a question. Do you feel better now?
Yup.
How about the rest of the class? Let's see
Yes.
some hands. Let's see. We got some hands out there. Okay, I see a few hands.
But there'll be some without the radical, though, too, right?
Yeah, and you just divide by, and I showed you that in the
In the video, yeah.
video. If you have,
Just make sure there are still going to be test
and
questions.
I'm making one up, okay? Let me look, see who's sending, I want to see hands. If I give you limit as x approaches infinity of x to the fourth plus 2x squared plus 3x minus 6 over x to the third plus 2. Well, what's the highest degree in the bottom? X to the third. So I'm going to take x to the fourth plus 2x squared plus 3x minus 6 over x to the third plus 2. And I'm going to divide everything by what?
3x.
X to the third.
Or, yeah.
All right, finish it. Every one of y'all finish it. Go ahead and finish it. Everybody finish that problem. Limit as x approaches infinity. Give you another minute. Okay. So that's going to take, this is going to go to x. That's going to go to x. This is going to go to what? This is x, 2 over x. That goes to 0. X, 3 over x squared goes to 0. 6 over that goes to 0. That's a 1. What's x over 1? What's infinity over 1?
Infinity.
That's it. So that's how you do these problems. Okay. Work on chapter 2, okay? And any questions? I received a couple of questions from Miss Woodall. I think Miss Woodall sent a couple, I think, and I haven't looked at them yet. And we'll go over those come tomorrow, okay?
Did you extend the deadline, or am I crazy?
I extended till today, I think I did.
Okay, I finished it yesterday. I just wanted to make sure when I
Well,
looked at it
I
today.
should have about 28, 29 students finishing it. But the 15, I'm not going to slow down the class for 15 people that didn't even try. So, anyway, any questions for me right now? I might
No,
extend
sir.
it one more day, but that's about it. Everybody good?
Yes.
Okay, I'm gonna shut off the sharing. Well, I meant not the sharing, the recording. There we go. And I'm gonna stop sharing.